Okay, this is the second half of Lesson 12 for Saxon Calculus. All right, last year we learned how to graph exponentials. And if you remember, to graph an exponential, we always made the key points for x to be 1, 0, and negative 1. So that when we graph these, 4 to the 1 is 4, anything to the 0 power is 1, 4 to the negative 1 is 1/4. So we came down here and it looked like this, basically. So that's what your exponential looks like. It's always positive, and when the base is greater than 1, it's an increasing. Same thing here with the natural log function. The key points x, y. The key points are x are 1, 0, and negative 1. And when we graph this, we'll get e 1, 1 over e. Again, the intersection here is x equals 0, y equals 1. An increasing exponential function, always positive, always positive. But the idea was that the key points are when x is 1, 0, or negative 1. Whether my base is greater than 1 or less than 1, increasing exponential or decreasing exponential, my key points were when x equals 1, 0, or negative 1. All right. Well, when we graph a logarithm, when we go to do a logarithm, we're going to think about this in the same way. Now remember, the way to rewrite this as an exponential would be to say 4 to the y equals x. So now instead of the key points being when x, instead of the key points being when x is 1, 0, or negative 1, the key points are when y is 1, 0, or negative 1. So when y is 1, 4 to the y, that's 4. When y is 0, that's 1. When y is negative 1, x is to the 1/4. So a logarithm only exists when x is positive. It intersects at x equals 1, y equals 0, and has the key points when y is equal to 1, 0, and negative 1. Now I want you to see that the inverse of this would be 4 to the x equals y. Remember, to write an inverse, you just switch the x and the y. So what happens? Those key points were over here, remember? Instead of the key point of the logarithmic function is 1, 0, the key point, the anchor point, if you will, of the exponential function is x equals 0, y equals 1. One of the key points here was x equals 4, y equals 1. The corresponding key point in the exponential is going to be 1/4. Switch the x and the y, switch the x and the y. Same thing over here with the logarithm, with the natural log, with the natural log. Remember the base of a natural log? This could also be written as y equals log base e of x. Rewrite this as an exponential. E to the y equals x. So now, instead of the key points being x is equal to 1, 0, or negative 1, the key points are y equals 1, 0, or negative 1. E to the 1 is y, anything to the 0 power is 1, and then we get 1 over e. So when we graph this one, it's going to look like this. There's my logarithm. X equals 1, y equals 0, x equals e, so that's about 2.7 something, e 1, and 1 over e negative 1. The equivalent exponential, if I switch the x and the y's, e to the x equals y. The inverse would have the point, instead of 1, 0, it's going to have the point 0, 1. Instead of e1, it's going to have the point 1, comma e. and instead of 1 over e negative 1, it's going to have the point negative 1 comma 1 over e. The exponential always has a positive y. The logarithmic always has a positive x. Always has a positive x. Those are our logarithm functions, how to graph our logarithms. We're supposed to be at the point where we recognize logarithms and we know roughly how to graph them. All right, so let's look at an example from our textbook. All right, the example in our textbook, I'm looking at example 12.8. Y equals negative log base 4 of x. All right, so I always think of this as negative y equals log base 4 of x. Rewrite this as an exponential. 4 to the negative y equals x, or 1/4 raised to the y equals x. Kind of did that fast. Let me over here to the side. 4 to the negative 1 times y equals x, right? So negative y is the same as negative 1 times y. So you can think of this as 4 to the negative 1 raised to the y. 4 to the negative 1 is 1/4 raised to the y equals x. All right, so again, key points now are when y is 1, 0, and negative 1. So if y is 1, x is 1/4. Y is 0, x is 1. Y is negative 1, 1/4 to the negative 1. Remember, raising to the negative 1 is taking the reciprocal. The reciprocal of 1/4 is 4. So this function is going to look like this. X equals 4, y equals negative 1, x equals 1, y equals 0, x equals 1/4. I'm up here at 1. So this is simply my original logarithm, which looked like this, right? Log base 4 of x looked like this, right? The negative log base 4 of x is just flipped that direction. Okay? Remember your AP exam, half of the AP exam is no calculator. So they're expecting us to be able to quickly have a general idea of what these things look like and how to graph them so that we can rotate them and everything else we need to do. So sometimes we'll rotate them, sometimes we'll use them as a base of a triangle or a base of a pyramid. So we've got to know basically what these shapes look like so that we can use it. All right, it's a little more difficult, but everybody grab your calculator and put in y equals the natural log of the absolute value of x. All right, now the absolute value, do y equals, clear, the natural log, so push natural log. Now to get to the absolute value, choose math, scroll across the top to where it says number, and then that very first one is absolute value, and then you can put in the x. Go to the end and push graph. And what you should see is something that looks like this. You should see something that looks like this. Well, here's what it looks like if x is positive. If x is negative, but I pretend it's positive, right? I put it in there as if it's positive. It's gonna cause this to reflect. That's not a very good reflection. Let me try again. Come on, eraser. Okay. It's going to cause this to reflect right. Where's my pen? And cause this to reflect about like this. All right, so that should be a reflection across the y-axis. I want you to try to zoom in as best you can with the 0, 0, or even down here further, and you're going to see that no matter what, it doesn't exist when x is positive. But the slope here, well, it's always increasing if x is greater than 1. It's always a decreasing function, right? As the x value increases, the y value decreases if x is less than 1. It's reflected across the y-axis. Okay.